batteries. We lock these around a fair bit in the field when we do surveys as geophysicists. And this has been a pet hate for many people in many years. These are lead acid batteries. They are reasonably durable in terms of being able to throw around, but they're heavy and they do deteriorate fairly fast. You can also only use 50% of the capacity of these. So we have something different. We've been tinkering with a new type of battery for a while, and this is a standard Peli case, but inside is something that is not quite standard. So here we have up to 20 lithium-ion cells gang together. You can run this as 24 volts or 12 volts. Each individual cell is a lithium-ion pack like this one. It's 10 amp hour, 12 volts in one pack, and together we can have 200 amp hours at 12 volts in this pack. So that here in capacity is the same as this here in lead acid. It only weighs a quarter of that. The other advantage we have here is that with the 200 amp hours, we can actually use almost 100% of that capacity. Whereas in lead acid, you only have about half of the rated capacity available. So these things are also much easier to fly with because we're using individual cells that are under 99 watt hour in total. We are able to take these on airplanes. So most airplanes, airlines will accept these. These are compliant as exempt for dangerous goods. And some airlines have a limit on how many you can take of these, but some airlines have no limit. So locally in Australia, the airline we fly with, you can take 20 of these. So I have flown with this pack here, fully populated. What I do is I disconnect each individual cell here, and I have these red caps that I put on to isolate it, and they all sit isolated in there, and I simply take this carry unlock it. So this has been through the x-ray and come through on the other side. Inside the individual cells we have these. So this is a lithium-ion 18650. This is a standard lithium-ion cell, actually the same as is in the Tesla cars. And with these you can make very large, very powerful packs. So with this we pull normally about 25 amps for the surveys we do. So we do time domain surveys, resistivity surveys. We also run this on a lot of lower powered ground penetrating radar gear. So the advantage is here that you have a lithium-ion cell. This pack is probably good for 10 years. It's airline compliant, and you also charge this very easily. So with this we use a standard charger. We can connect 5 chargers at a time, and they cycle through and charge this pack still overnight. So it's a very easy system. It is one of a kind. At the moment I've got a 25 amp fuse in there. I really should fuse these individually as well, because inside we have 5 boards for charging that shouldn't individually really go over 5 amps. The way you power your equipment when you're in the field is with standard pole connectors here and here, which are exactly identical to these. Actually, the 2 missing here are now sitting on this box here. So we were due to replace these batteries because they are now 10 years old and they were dead. But we decided that this is the way to go instead. We will not be buying any more lead acids, and we'll be using these flexible lithium-ion packs from now on. So I hope you found this interesting. Lithium-ion is a great technology. If you got questions, send us a comment or an email, and yeah, consider lithium-ion next time you go in the field.